Okay, Chapter 1, review of zeros, max min values, increasing, decreasing, and I even threw in constant. So the zeros of a function. We're going to just talk about rational zeros right now, but we could talk about irrational ones. You could get x squared equals 3, so x equals plus or minus 3. You can usually get these by factoring and synthetic division. Here I just chose to review grouping. And so I factored out the x squared, and I have x minus 6 not once, not twice, but thrice. X needs a negative 9 to make it 9x. Once you're at x squared minus 9, you can factor it, or you can say x set that equal to 0 and x squared equals 9, so you get plus or minus 3. But the zeros are 6 and plus and minus 3. Again, I just did another review, because when we did grouping before, we ended up with just x minus 16, not x squared, so you could factor and get plus or minus 4, or x squared equals 16, and you get your plus or minus 4 that way. So zeros. Now what if it's messy and you're going to get a decimal one because they want a decimal approximation? And it's not like I've got x squared minus 7 there where you can say plus or minus root 7, but it's something that you can't factor, and if I do get exact answers, it has no meaning. We just go to the calculator, we get in graph mode on our TI Nspire, and we enter this function, and then the keystrokes are menu, select analyze, select 0. And at this point, you're going to have to do this 3 times if you're going to get decimal answers. We're going to have integral answers, so you could just read them off the graph. And when you do that, you just go a little left, press enter, a little right, press enter, and then out pops your answer. And then you have to do menu analyze 0 to get the next one, menu analyze 0 to get the third one. In this one, you could have just read these off of your graph for the very first function. Now, what is a max? A max is the largest y value possible, and the min is the smallest. Now, whenever they say max, they mean absolute max, and when they say min, they mean absolute min. Sometimes there's in-between points where you dip and go up and down, and those are called relative or local, and I'll speak to them in a minute. Now, we typically do these if it's not something really obvious. We enter the function in our calculator. So we go graph, enter the function, menu analyze, and then if we're looking for the max, we select max. If we're looking for the min, we select min. And then you put your cursor a little left of the max, a little left, enter, and then a little right, enter, and you do the same thing for the min. For example, here is this function. If you look at your calculator, it would look like this. It would have an endpoint at 6, 0. So a little left, you'll see this vertical line. It's dotted. You press enter, and then you move the cursor a little right, and you press enter, and then it will tell you all your ordered pair. You can get as many decimal places as you need. The max point is 4, comma, to 2 decimal places, 5.66. The max value is always the y value. 5.66 is the approximation. It occurs at 4. There is no min value because this goes to negative infinity. Then I threw in a parabola, which you're familiar with, that opens down. So again, I'm going to do the steps, enter the function, menu, analyze, and of course max. A little left, press enter, cursor a little right, press enter. It then tells you that this ordered pair is going to be 0.25, comma 3.25 to 2 decimal places. So the max value is 3.25, and it occurs at 0.25. And again, no min value because that's negative infinity. Now, how do I know where a function is increasing and decreasing? I'm always confused by students telling me they struggle with this. Increasing already indicates that the y's are getting larger. Decreasing already describes that the y's are getting smaller. So when I say where is y increasing, I don't want to know the y values. I use the word increasing to know I want to know where it is. So I'm looking at where or when the x's are that let the y increase or decrease. Now, there are nice graphs in your notes on page 10 and 11, and they're well done, drawn on a calculator. Not so here, so live with it. All right, so here's my function. Notice it goes down and it goes up. So I have a minimum point that's a relative one because it's not an actual min. It goes back up. But notice this is negative infinity. This is positive infinity. So there's no max, there's no min, but the function from left to right is decreasing, increasing, decreasing. I know what the y's are doing, so notice how I underlined the x's. So my x's go from negative infinity to 2. Negative 2, then negative 2 to 0, and then 0 to positive infinity. Notice I'm not looking at the y's, I'm just thinking about the x-axis. So when I look at this function, when is it decreasing? When the x's are negative infinity to negative 2, and when the x's are 0 to positive infinity. When am I increasing? Well, I'm increasing when x is negative 2 up to when x is 0. So I'm increasing on the interval negative 2 to 0. Now, this is a min of sorts. It's a local or relative in relationship. It is a min. So I call it a relative or local min of, what is the relative or local min? It's the y value negative 3, and it occurs where? At the x value negative 2. I have a relative or local max of 1. That's the y value. When does this happen? At 0. So it happens at an x. It is the y. So let's look at example 2. In example 2, you see it increases. Now it's constant, and then it decreases. So when is it increasing? Well, it's increasing as x moves from left to right. So x is negative infinity to negative 1. It's increasing. What happens between negative 1 and 1? It doesn't change. So between negative 1 and 1, it's constant. What happens starting at 1 as I move to the right? It's going down. So from 1 to positive infinity, it's decreasing. Now notice there is a max. There is a highest y value of 2. And it occurs quite a bit. It occurs for every value from negative 1 to positive 1. So I need to show you that when you're constant, you're going to get numerous values. Again, there is no min or relative min, absolute min. There's nothing because these go to negative infinity. Let's look at the third and final graph. The final graph, notice there's no absolute maxes because these go to positive infinity. But as I'm moving from left to right, from negative infinity to negative 2, I'm going down. From negative 2 up to 0, I'm going up. From between 0 and 2, I'm going down. And from 2 to positive infinity, I'm heading up. So the graph increases between negative 2 and 0, and between 2 and positive infinity. See, negative 2 and 0, 2 and positive infinity. The graph is decreasing from negative infinity to negative 2 and 0 to 3. So over here is negative infinity on the x-axis, and that's heading to positive infinity. To negative 2, it's decreasing. From 0 to 2 on the x-axis, the y's are going down. Now, I do have a relative max. It's not absolute. It's in relationship. So my relative or local max is 9 and occurs at 0. So relative max of 9 and it occurs at 0. I do have mins. The lowest point, the lowest possible point on this graph is -7. So that's the min, also known as the absolute min. They don't have to use the word absolute to indicate they want the absolute. It's always just saying min max implies absolute. They have to say relative or local if they don't want the absolute. And so the absolute min is -7, and it occurs twice, at 2 and -2.